Welcome everyone, thank you for coming. My name is Frederick Jansen, I'm the CEO and founder of Alphapura Robotics, and we are global solutions makers. Our mission as a seed stage startup company is to become makers of global solutions by developing and innovating recycling manufacturing systems and communities for homes and businesses to help solve major global issues related to inflation, unemployment, poverty, and environmental degradation. So imagine for a moment if a single product design could help solve most of the problems on Earth. And imagine if this was an American technology and could solve problems like the freshwater crisis, poverty, emergency preparedness, the depletion of renewables, pollution, and mass extinction of 40% of the species on Earth since I was a kid. So the list is long. What would such a technology look like? So it would come in personal, family, community, and industrial sizes, and would have an artificial intelligence that a complete novice could interact with in order to transform their meltable garbage into millions of new products for virtually very little. And by engaging the artificial intelligence, basically they'd have access to a 3D scanner, recycler, 3D printer, CNC machine, injection molder, paint gun, online community, and trade platform. So the user experience, imagine walking into a room to a fridge-sized machine that basically recognizes you're there. And then basically through the process of questions and answers, a complete novice would be able to visually and verbally understand how to process their meltable trash into new products. And essentially what happens is that the machine would guide the user to put homogeneous materials of a certain melting temperature into a grinder, which would grind it into feed. The feed would then go on top of the machine and feed subtractive and additive manufacturing. So the market opportunity here is benchmarked on the 3D printing market alone, which ranges from 5 billion to 40 billion, depending on the valuation. It's set to double by 2020, but some are saying 40 billion by 2020, and there's even more aggressive valuations. The thing is that this $5 to $40 billion market is wholly dependent on $1 billion worth of consumables. So manufacturing with recyclables would in effect disrupt the entire market. And again, these are conservative valuations because they neglect substitutes like CNC machines, injection molding, and the like. So how could we compete in this space? Well, other than being a small organization that can adapt more readily than a large organization, we'd be able to build new products with essentially a free building material versus expensive consumables. We'd have greater functionality than our competitors. We'd be able to price compete with the market leaders. We'd be easier to use than competing systems because of the artificial intelligence. And most importantly, we've secured and continue to secure intellectual property to protect the same. Last, we could transform a global problem, pollution, into many global solutions. So the pro forma financials for our seed stage company has two revenue streams. One, a 7 to 10% licensing deal with the top 5 to 8 3DP market share leaders by 2020 for $100 million to $4 billion in revenue. The other is an online retail and wholesale sales of the units for 20 to 50 million. Well, if it only costs us $10 million to make the 10,000 units, then we net $10 million in profit, and that's the least amount that we would net. So the way we would spend the money is with a $10 million investment would be 50% for production, distribution, 20% for sales and marketing, 10% to build our social media platform, 5% for capital expenses and equipment, 5% for human capital, 5% for research and development, and 5% to protect and expand our IP. So our call to action at 1 million cups, basically we need a venture partner investor who can help us secure licensing deals or who can fund and guide our growth. So help us save the world in a profitable manner by contacting me, Frederick Jansen, at alphapurarobotics@gmail.com. Thank you. Spare.
Yeah, so Frederick, you, we always ask, what will you do, what can the community do for you? And I think you kind of just addressed that.
Yeah, exactly.
Is there anything else you'd like to say about that?
Just champion the technology because, it's an American technology, and if you can solve most of the world's problems with one technology, do it, just help us out.
Okay. So now we're going to open it up to questions. You can call on the folks yourself unless you want me to moderate that.
Oh, sure. Go ahead.
Where are you in the process? Do you have a product prototype?
Sure, yeah. So we've we've got 2 prototypes on the go right now, the personal size and the family size. We have the process, patent, trademark secured, but then we're also basically we've expanded that, so we also have an additional product and process patent coming that we plan on filing. So that's where we're at with respect to that. And then with respect to everything else, we're fairly new. We started in May, and then that's when we first formed the company, and that's where we're at.
But it works.
Pardon?
It works.
Well, there's different models.
Yeah.
Some things work
Cool.
better than others. So basically, we're trying to figure out how to make more materials work.
I want to hear more.
Yeah?
Thanks.
Anyone else? Yes, Pat?
So this is a really big hardware play on your end, right?
Pardon?
It's a big hardware play for you guys.
You'd think so, but actually it's surprising how much technology has been developed and software to be able to actually make this happen pretty quickly.
So you're utilizing other people's machines and software and stacking it to create your product.
So currently, yeah, we're prototyping with Arduino and let's see, I always forget the name of this, but Blackbone or something like that. Basically, my prototyping guys are the ones that are hands-on with the machines, and then the idea is to then eventually go to we've talked to like some manufacturing consultants, and you can go and basically have this open source platform be turned into a closed platform, and then basically it's proprietary after that. So.
Cool. We should talk about that more, but love many Tuesdays.
Love to, yeah. We are the Tesla meets Walmart of green manufacturing. So basically, we'd like to take almost this fully automated machine, bring it to a price point where basically homes and offices can benefit from it, and that's the idea.
Okay.
Yeah.
Can you give us a few examples of how you might use it in your home?
Oh, absolutely. So basically, in everyone's garbage and recycle bin, you're throwing away this building material is what you're doing. And someone else is using it. The county's using it, or different people are using it. And what we want to do is basically have every home and office, ideally have this as an appliance in their home to basically be able to recycle their materials into new products that they might need. And so you could make a chair, you could make a boat, you could make a house, you can make a number of different things out of garbage. The thing is that basically it's just not being done yet. So that's
It sounds like a replicator. Is that what we call it on Star Trek?
Right, well, not far off.
Yeah.
That's the idea. So, but that's the idea. And if you think of the huge cost savings that pretty much everybody across the board could realize for some of the things, like think of green energy, for example. To make renewable energy more affordable, you would basically be able to make the scaffolding out of what would otherwise be garbage. You could basically apply this to almost every industry. So.
Okay, we've got some questions.
Yeah.
Just a question, kind of understanding. So, are you guys trying to do where, since you say that we're giving our recycling to the counties in different places and they're taking it and they're making revenue off of it?
Sure.
Is there an ability for the average consumer homeowner to recycle their own stuff, almost like solar, where they can put solar on the house and sell their solar and their bill goes down? Is it the same type of philosophy where they can take their recycled and sell it themselves? And
well, that's what the trade platform's for. So if you wanted to basically, in your online community, if you wanted to sell your materials, sell your designs, upload your designs using the 3D scanner, and with the 3D scanner, any individual could basically scan any three-dimensional object, depending on the size that they purchase, to be able to basically have a manufacturing file for that object, and then they'd be able to make it out of homogeneous
so you
materials.
can build an inner charge box out of it?
Well, absolutely. You're my first customer.
A lot of plastic.
Yes,
a lot
sir.
of recycling.
So when it comes to, I guess, the inputs that you're putting in there, how much do the inputs affect the quality of the output?
Well, that's the thing. It's different. So first of all, every one of the pieces of garbage, if you will, in your recycle bin has a different optimal melting temperature. So the first thing to understand is that basically each one of these bins here would be a dedicated, so you'd have a dedicated extruder head. You'd also have a dedicated bin for each type of material that you need to use because of their optimal melting temperatures. Because otherwise, different things won't play well together. So sorry, I think I didn't answer your question. Can you ask me again?
Well, so like if you have a whole bunch of aluminum that you have to recycle,
Yes.
it needs like glass.
Right.
Are you able to, how
So-
agnostic is it to what the materials that it needs?
So here's the thing: is the hotter you go, so the higher the optimal melting temperature for a material, the more difficult it is to build with, and that's basically going to be our design challenge, or someone else's. Because if we license this to the top 6 to 8 companies, then we don't even have to do this. What we're doing, why we want the money to basically make 10,000 units, is to influence the licensing deal. And basically, if the licensing deal doesn't come through, then we just start to take over the market, and that's the idea. Yes.
For the one that you have, like for the common consumer, like how big are they in the house? Like
So the personal size one would be desktop. The family size one would be the size of a fridge. The community size one would be the size of a van, and the industrial size one would be the size of a house. So, and in China, they're already printing houses out of concrete.
Yeah.
So we just want to print them out of garbage. Yes, sir.
A nice early place for testing might be like high school maker spaces.
Oh yeah.
That just sounds exciting.
Yeah, and theme parks and
Yeah.
engineers and prototyping places. Yeah,
Yeah,
there's
cool.
yeah, it's endless. So. Yes, sir.
So you want to build 10,000?
Well, honestly, that's we would like the licensing deal,
Right.
but if we can't get the licensing deal, then we want the money to build 10,000.
But you need to probably have a working prototype to
Absolutely.
do the licensing. How far away are you from having a working prototype, and how are you funding that?
So it's self-funded between myself and one other fellow, and we've got 2 prototypes that we're building right now, and we expect to basically be done by the summer. So we're pretty confident that we'll have them up by the summer, by the end of the summer. But again, if we can get a licensing deal, then we don't actually necessarily need it, because people have large portfolios. 3D printing companies have large portfolios of IP, and some people just want the IP. So if we can license it to them, then that's the fastest way to get money without giving up equity.
So how are you finding potential licensees?
Well, we just identify the top players in the market, and really there's 2 of them. But then after that, there's a cascade of other companies that are in that space, and so we identify the top 5.
Who are the top 2?
I believe it's Stratasys and 3Dsys.
And how are you approaching them, or are you waiting until you have the prototype?
Well, here's the thing. So we're waiting until we have our first action call or something like that at the U.S. Patent and Trade Office. This summer, we have an attorney or a law firm that basically has agreed to represent us should we need it. But we're pretty confident that we're going to get it because we've added some really novel aspects.
So
to
you've
the
actually
machine.
filed the patent?
Oh yeah,
So
the
it's
product
patent
patent, the process patent, or so the design patent, and so 2 provisional patents, 1 non-provisional patent, another non-provisional patent coming up, and likely another non-provisional patent.
And I'm just curious, who helped you file your patents?
Basically, we started with LegalZoom. They put us in contact with a law firm, and the law firm and professional patent illustrators and research services, and collectively helped us file the patents. Okay.
I got a question about the technology. I'm wondering about inputs and outputs and how much energy it takes for you to recycle this stuff versus the benefits of the outcome.
Well, that's actually, I don't know specifically what the power requirements will be as of yet. Because I'm not actually the hands-on guy, I'm kind of more like the business guy. But if you'd like, I'll give you a card and I can see what I can find out and get you that information. So, Give me 1 second, I'll get you a card.
Other questions on the card?
Across me right
Is it just trash or is it garbage too?
there. So basically it's
Garbage
meltable.
being food stuff. I
No,
guess.
not that stuff. So basically recyclables, meltable, things that can melt. So it's really the butter and frying pan model. You can render a solid into a molten state, and then you can do whatever you want within, and then basically, in this case, it's computerized numeric control, CNC technology that basically allows for different tool heads to basically be clipped onto that technology, and what it does is it operates, using like CAD programs and that kind of stuff, takes a three-dimensional image, slices it down for 3D printing, and then basically allows you to create an object. But then stationary 3DP would allow you to do injection molding, which is part of the machine. And then the CNC machining, we would basically stationary injection mold a block of garbage, or say a block of plastic, plastic number 1, for example. And then a mill drill would basically create whatever object you wanted to create using the machine.
So this sounds like amazing technology, but my question for you is, how did you identify the problem and how did you validate that, or how did you validate that your solution is addressing a problem that people have?
Okay, well, that's basically comes down to the story of how all of this started up. And so what I had done is I patented a 3D printed water purifier capable of converting the world's oceans and dirty water into fresh water for drinking and food production. And that was going to basically help 2 billion people who are being exposed to the freshwater crisis. But the thing is that when I went to go look on, I wanted to 3D print these things, and they wanted $400 worth of materials to make a little water purifier this big. It was a solar cell. And so that was cost prohibitive. And then one day when I was taking out the garbage, it just struck me, and I'm throwing away all this material that I could basically melt and create an object out of. And then it started to hit me, and all the wheels started turning, and I was like, well, hold on a sec, wait, and then that's how it hit.
But how did you validate that idea in the market? That this is like a really cool technology,
Sure.
and it's something that you think would be beneficial, but we always teach startups to go out to the market to get information about whether or not what you're spending all this time designing is something that people are actually going to use or want or pay for.
So as a user of 3D printing myself, I can tell you that they'll tell you it's easy, and it's not. It's actually quite difficult, and you need it's a steep learning curve, and all these little things can go wrong with it. But if you've basically got a system that's going to guide you visually and verbally what to do, flashing light, putting your garbage in.
But you're still talking about your technology. What have you done to go out to the market to sort of test your concept to see that there's demand for this?
I guess it's speaking to people who are in kind of the manufacturing world and understanding that basically, they'd like to make things, but they don't have the knowledge. Speaking to entrepreneurs, they'd like to prototype, but they don't have the knowledge. They don't have the skills, and so it's just.
So you've done like dedicated market research, or is this
Not yet.
anecdotal?
No, not yet. But the thing is that it's so hot right now, and the 3D printing market's exploding for personal use and desktop.
Well,
so
my
I hear
personal
you. I hear
opinion
you.
is that this would be a good time for you to go do some of that market research.
Sure.
Particularly before you finish your prototypes.
Okay.
That there could be some information that you learn from your target audience that might influence how you design your prototype.
No, that's great advice. I guess also, to kind of build on that, so because we know that the 3D printing market alone is just going to soar, we're riding on that, right? And then all these other technologies, they're great. But honestly, if you think about it, 3D printing is just wickedly slow. So what you want to do is basically, the ideal combination of using that machine would be to basically make blocks of materials and then CNC them, because you can make prototypes, products very quickly that way. And then for somebody who wanted to, for example, become an entrepreneur, they buy one of these machines for say like $2,000 to $5,000. But the thing is that as soon as they've produced enough products and sold them, they've not only paid for the thing, but basically now they're generating a profit. So.
Very cool. Minecraft in real life.
Yeah,
So-
exactly.
All right, one last question.
Yeah, I just to roll off of hers, I think what she's trying to say is that I'm a little confused on it. We're talking about desktop models, home models and all this, but I mean, as a consumer, I mean, you have to go out and check the market, like, as someone like me, gonna wanna put one of these in my house. But you're talking more about the 3D printing, which I have no understanding of 3D printing.
Right.
And most consumers out there are gonna have next to zero knowledge. So what's the benefit and why would I wanna put this in my house?
So for sure, you know, what you're saying is important. I guess the idea is that anyone who's going to buy a 3D printing in this exploding market is going to want a better machine, a machine that's easier to use and a machine that's cheaper.
I understand, but I'm
That's
talking about as a
basically
consumer. Because
Right,
you're
well, that's
talking
the
about,
consumer.
you know, desktop models, which I couldn't even envision a desktop model that does something like that
Mhm.
in my brain, which is not my, you know, so I'm just trying to understand that part.
No, that's fair, yeah.
You know, because we're talking about the consumer side. I think you guys are more weighing on the industrial side.
It's more that we understand that basically the 3D printing market's taking off, and we're going to give something that's more than a 3D printer.
Right.
And so basically, and we're going to make it better, you know, more convenient and cheaper, and so that's the idea. Yes.
Yeah, I think another way to say it, maybe because I'm hearing you all, is I want you to put me on your market research
Mhm.
project,
Okay.
because I need you to come tell me what the heck this is. Like, I'm super curious.
Yeah.
I don't know why I need it in my house. I don't know if I'd ever touch it. I don't know how big it's gonna be. So, but I think you need to hear that. I
Okay.
think what we're all saying is you need to hear that from somebody that's actually gonna be dependent on your model.
Sure.
On your product, because that'll help you decide maybe even some different functionality that you want to include or change some things that we've got so far. But certainly, I can tell you love what you're doing, and I can just feel like it's got a lot of potential. I have no idea how to even picture it in my brain, so or whether or not I need it. So, but seriously, I would love to be part of
Sure.
that
Well,
process.
let me get you a card as well.
So Tosca, go ahead and ask your question.
Oh.
There you go.
Because I spend a lot of time at Hacker Lab, so I watch 3D printers all the time. So I understand what he's talking about. But when I saw that picture, I'm more thinking about the fact that we throw out so much trash. And a lot of people don't even recycle. So the idea that we could do something with it, like that is sexy. You want to talk to people and you want to get that validation. And when you said $2,000 to $5,000, then you're knocking out people that are like, I would try that, but that's expensive. Like if I don't have a dedicated reason already, I'm not necessarily going to do it. When I can throw out, put everything in the blue box, and the county will take it. That's it. There's a big disconnect between I can throw it out and I'm going to pay $2,000 to do something with it.
And that's
So
fair. They're expensive.
you want to start talking to the consumer, like what's going to actually get them excited about it if they don't have already an idea about 3D printing something, like that they would just, being green, protecting the earth, not putting that back out there so that it just has to biodegrade in a landfill somewhere, that we can use it, we can turn it into something, we can control it. So there's that aspect, is what we're trying to talk about. When you're not talking to the tech world, you're not talking to the building world, you're talking to the average person.
No, it's valuable feedback because obviously that price point is not a price point that a lot of people would be comfortable with. But the thing is, that's what MakerBot's doing right now, for example. So if we, and that's kind of our target, customer, is that if MakerBot's in Walmart for $2,000 to $3,000 and we can come in lower than MakerBot with greater functionality, cheaper, and more convenient, then the idea is that basically we can put them out of business. But if we tell them that, then basically, hopefully we can get a licensing deal with them, which would give us enough money to basically continue.
Last question, Ari.
Me?
Yeah.
I was just curious because how much of the IP for designing this, are you just putting things together that already exist? Or are you going to have to create new things? Because I know in the 3D printer industry, for rapid prototyping right now, one of the reasons it hasn't reached kind of like general consumer level is essentially resolution. The resolution is just not there yet. So I'm curious, are you going to make that leap to be able to have the resolution to have like general consumer products?
Sure, it's a great question, and I know that resolution is really important to some people. It's going to be less important to us, and the idea and the reason for it is really it has to do with the materials and how they flow. So it's more being able to take something that's worthless and turn it into something that's valuable. And so maybe it won't be as beautiful as like the fine grain, but at the same time, I think it has great promise. So.
Okay.
All right, thank you, Frederick.
Thank you guys.